Welcome to another episode of Tom's 2D game programming tutorial series. The last video in this series was a very simple one. We just put a letter on the screen and we played with that. We played with how fonts appeared on the video screen. And so now this week we're going to take the next logical step. We're going to put pictures on the screen and do some things with lines as well, maybe a dot. I know that we seem to be starting a little slow, but definitely got to get the basics down, and we will soon get into the really interesting and meaty stuff of making video games. Another thing we're going to be doing this week is actually putting sound on our computer, and by that I mean we're getting our computer to play a sound for us, which of course, since video games are audio-visual, which means visual and audio, it's important to have sounds too. So we'll do that this week. Now, if you haven't done last week's tutorial, I certainly suggest that you go back and do that one first, because it involves a great deal of the basic setup. Remember that in this series, we are using Visual C# 2010 Express Edition from Microsoft, which means a Windows computer. And on top of that, we're using something called XNA 4.0, which was made by Microsoft as a tool set, a software tool set for making games for the PC and the Xbox 360. Just like last week, we're going to start by opening up our Visual C# 2010 Express Studio tool, which is called an IDE, or Integrated Development Environment. So it combines an editor and a tool for modifying and you putting your files together, because multiple files go into a piece of software, and the compiler, which takes your programming and turns it into something the computer can understand, and lots of other fancy tools besides. One of the cool things, as I mentioned last week, Microsoft does not skimp. It knows that its real customers are computer programmers, developers who want all the tools, and Microsoft works hard to give it to them. So first things first, I'm going to go fire up my C# 2010 Express Edition and create a new project. Now, I would like this project to be called ArtSound. It's not a very inventive name, but we've got to name it something. And once I've typed that in and made sure that the location is where I want it to be, and make sure that it's an XNA Game Studio Windows Game 4.0, then I hit OK. And just like last time, it takes a bit and builds me a brand new project. Brand new empty project that does the minimum, and certainly not anything that we want it to do, but it works. To find out that it works, we're going to hit F5. Boom. Get our blue screen of happiness. So that's our basic empty program. All right, next step, we're going to go out to the download link that is provided at the bottom of this video, and we're going to go get our zip package, which contains the necessary files to make this project. And I'll get to this page, which you can see has a link to my data files. I'll click on that. I'll download it. Now, of course, you may have a different browser than me, so your download process might be a little bit different, but I'm certain you can download files on the internet. So I've got my files, and I've got 4 files in this zip file called ArtSound code and data files.zip. Notice that they're different. I've got a robot.wave. That's a sound effect. And the .wav, or wave, file is sound. There are other sound files, like MP3 most notably. But for XNA, we're going to be using WAV files. Also, we've got a face.png. PNG is an art file format. So this is a bitmap, which we described last week as a 2-dimensional array of pixels. Right? Pixels that come with each component of red, green, blue, and sometimes alpha. So basically, it's a picture. It's a picture file. There are other pictures, most notably JPEG is a picture file. But PNG is a very nice one. We'll use that. And then there are two other files in this zip package, helper121.cs and game1.cs. And those are C# code files that we're going to copy into the correct directory and add to our project. So let's do that now. I'm going to take my robot.wave and face.png, my data files, and I'm going to extract them. Where am I going to extract them? I'm going to extract them into my ArtSound content directory. Now that I've copied my data files off, I want to extract my C# programming files into the other directory. I'll extract and put it in ArtSound. And yes, I want to overwrite my game1.cs file. The Microsoft already made a basic template game1.cs file for me. I'm just copying over the one that does more. Alright, we've copied all that. And if we go look in our folder, and we'll find that Microsoft just made us an ArtSound. And there we go. I've got my game1.cs, my helper1.cs, and incidentally a program.cs. Then in the other directory, ArtSound content, you can see I have my face.png and my robot.wave. Now last week I mentioned that it's not enough just to put your data in the correct folder. You must go to the Solution Explorer of your C# tool and actually affirmatively add all of that code and data to your project. So let's do that now. Alright, so here on ArtSound, I'm going to add existing item because we already have the file, and it's called helper121. I could have added game1.cs, but it's actually already added, just not the version that we copied over. ArtSound content, we have to add existing item there as well. We have to add the face.png and the robot.wave. Now, last week I pointed out that helper121 needed a sprite font to be added to the project in order for everything to work. Well, nothing's changed. Sprite font is still necessary when we're drawing on the screen and when we're using helper121. So let's go ahead and create a sprite font for this solution as well. I'll go back and click on ArtSound content, add new item because we're creating one. I'll go to sprite font. Sprite font 1 is the correct name. I'll hit add. Boom, we've got a sprite font. Now, we've added all the proper data to the project, and we've added all the proper code to the project. So if I hit F5, we should actually see something interesting, and hopefully it won't crash or anything. Let's try it. Boom! Now that's interesting. We've got a lot going on here. Let's unpack it in the code. Here's the top of our game1.cs file. Notice that the namespace is ArtSound because that's the project name. And we've got a game1 class here, and we've got the magical helper121 object as part of that class. Over here in our load content function, we actually fire up, create, and set up our helper tool, which is nice. Then over here in update, something's going on. These two lines are fairly simple, but they do something very interesting. Notice I have comments in the code. Remember, white space is a gift from your loving creator, and you should use it. And in this case, comment. And this comment says play a sound when you press the space key. So, what sound? Well, the file says helper play sound content robot. That's this file right here, robot.wave. But it doesn't say robot.wave. It just says robot. What's going on? Well, if you click on the robot wave file here in ArtSound, you get the properties for that object, and you see that the asset name is actually just robot. Now, I explained before, but let me explain again, that Microsoft takes your data files, like the WAV file and the PNG file, as input, but that's not what's really actually being loaded into your program. When you add the WAV file to the project, Microsoft converts it to its own special format for your program and stores it in another directory. And then that data file is what gets loaded at so-called runtime. It gets loaded at runtime. In other words, it gets loaded up when your program starts. So this file might have started out as a WAV file, but when Microsoft gets through with it, I'm not sure what the file format is, but it's not WAV anymore, and so the WAV is not important. So we'll just go by asset name, which usually takes the file name and shaves off the suffix. So helper play sound content robot. If that's correct, then when we hit the space bar, we should play a sound and we should hear it. Let's try that. Let's run this program again. I have it on my screen. I'm going to press the space bar. That's weird. That's a cool robot sound. Or at least a robot sound. I have no idea how cool it is. What am I saying? It's up to you whether it's cool or not. But it does play when I hit the space bar. Alright, and we're hearing something. Alright, so let's continue looking at the code. That's all that's happening in update. But down here in draw, there's a lot. Notice that just like normal, the very first line of draw is where we clear the screen to blue. And then we do a sprite batch begin, which we always have to do when we're drawing stuff. And then we draw a bitmap at a location on the screen, content face. So this is the picture that we loaded up as a 2D image. We're sticking it on the screen at 100, 100. Now where is that on the screen? Remember last week I said that all modern computer screens started at 0, 0 in the upper left corner of the screen. And this is no different. When I say corner of the screen, I mean corner of the application, which might be a screen or might be a window. In this case it's a window, so in the upper left of the window we draw the face picture. Now here we draw a red box, which is filled. In other words, it's not an outline, it's an actual red box that's red all the way through. Then we draw a green diagonal line. It doesn't look very green sometimes because it's really only 1 pixel thick, and on modern computer screens that's very thin. So it's a very thin line, but trust me, it's green. As you can see, green was our argument to this function. Then we draw a yellow dot, and the comment says single pixel, very small, in the upper right hand corner of the game window. Let's go fire up the program again and look for that dot. Yeah, here it is next to the X dot. Now I can move my pointer to try and show you exactly where that is. Oh, my pointer disappears. I just don't draw a pointer when the pointer is over the application window. Now that's a choice. That's, we could fiddle a setting. There's code that would let us turn that back on. But when we're talking about video games, we're usually talking about custom user interfaces, and those custom user interfaces usually mean a custom mouse pointer. There's absolutely no reason, very easy, why we can't draw a mouse pointer, whatever we decide it to be, at the location the mouse is at. And that would solve this problem. But currently in our code we do not draw a mouse pointer, so there is no visible mouse pointer for our particular application. But you can still see, if you look very carefully, there's a little yellow dot in the very far upper right of the screen. And finally, we draw a yellow rectangle outline. And you can see that's a yellow rectangle that's not filled, it's just an outline around the red box that was filled. And after we finish drawing everything, we do sprite batch end. And we've done. And boom, that's the end of the program. So let's look at this program one more time. We've drawn the diagonal line, the red filled box, the yellow outline box, the bitmap image. Happens to be my own art. Don't you think it's beautiful? It's something called programmer art. It's kind of a joke in the video game industry. Programmers are not artists, so they throw together images and don't expect them to be any good. But that's okay. If your program's good, find an artist and replace your crummy programmer art with good art from an artist. And finally, in the upper right-hand corner, we have a tiny little yellow dot, 1 pixel exactly. If you've gotten this far, if you're seeing what I'm seeing, then you've got a functioning version of this program. As always, I have a rubric associated with this tutorial. And let me go through that rubric with you now. The rubric is a list of things that I would love to see you do with this program. Extra code you can add to expand how this program works and help you explore how to do the things that this particular program is trying to teach you to do. Number 1, multiple lines on the screen. I've already shown you how to draw one diagonal line, and if you notice in the code, that diagonal line really just has a start point and an end point, which means it doesn't have to be diagonal. It can be anywhere on the screen, it can be as short or as long as you want, and it can be in any orientation. So draw lots of them. Number 2, draw more than one image file. I just got through saying that my little piece of scary yellow face was programmer art. Well, that's fine. Go find some really nice art on the internet and make it a 2D image in a PNG format and store it in your project directory and add it to your project and then draw it on the screen. You can draw the prettiest picture in the whole wide world. Number 3, you can see we draw a tiny little dot on the screen, but you can't really see it. You probably see it more if we draw a lot more. Why don't you go ahead and draw 10 or more dots on the screen in different locations. Number 4, you see we have a red filled box on the screen and a yellow outline box on the screen. But of course, you could put those anywhere on the screen you want in any color you want. So try that. Put multiple boxes on the screen. Number 5, something that moves around the screen. When we were doing the rubric last week with the little letter, I also asked you to move things around, and I pointed out that basically moving things around in a computer program is about replacing the constant X and Y positions with a variable, and then modifying the variable in the update function, adding 1 to it every time, or something like that. Give it a try, see what you get. Number 6, something that blinks. Make a counter variable and use it and test it and say, well, if it's even, draw. If it's odd, don't draw. That's a good, easy way to make things blink on the screen. The next one, let's make something that shows a changing state, like a score. Now, we did that last week with fonts, but as anybody who's ever seen a health bar in a fighting game goes, make a bar that goes up and down depending on something, or side to side, or something that grows bigger or smaller depending on a game state. Here's another one. Make a bunch of art that together make a pattern on the screen. Another idea is to put graphics on the screen that respond to keyboard input. This is really what most 2D games are all about. You put the figure of Mario on the screen and you use the arrow keys or the joystick keys to move them around, right? So you're putting a 2D image on the screen in a location that's defined by variables that are then modified by keyboard presses. And finally, how about graphics that tell a story? We used text to tell a story last week, but anybody who's seen a picture book or a graphic adventure knows that graphics tell stories just fine. So throwing up a sequence of artwork that tell a story, perhaps after you hit the spacebar each time, is a great idea. I hope that looking at this code can clear up misconceptions and help you understand how to do basic AV, audio-visual work on your game. Of course, that's the non-interactive heart of video games, is putting stuff on the screen and playing stuff out the speaker. Everything else is about input, which we'll certainly explore in later tutorials. I'm Tom Robertson. Thank you for watching, and I hope you have fun.